Introduced in the 1950s, most transistor radios used them. And because of their small size and difficulty to service, most radio and TV shops refused to work on them. Howard Sams helped a little bit in helping the servicemen out by introducing what was called circuit trace. Each one of those little islands there was assigned a number, and on the schematic was the corresponding number. Gave a better map as to what was going on. But still, technicians wanted something that would be a little bit quicker to service. So Philco, in 1960, introduced this. Philco trace. The trace in Philco trace stood for Transistor Radio Automatic Circuit Evaluator. And its principle was simple enough. Most Philco radios in the 1960s, transistor radios I should clarify, had their circuit board foil side open to you when you opened up the case. So in order to service them, you took each one of these cards that corresponded to the model that you were working on. In this case, this is a T51. And you laid it on top of the circuit board in the proper direction. Once you did that, it instantly gave you a map of where everything went. Antenna, oscillator, first IF, second IF, all the way down to the audio. And on top of that, as you can see, there's little tiny holes. These come out, they're perforated. You put your probe on top of each one of those. That will correspond to the island which this particular circuit is on top of, and give you a better chance of doing a quicker diagnosis. The inner cover of the manual also gave you an idea how to use them. They called them trace panels. You position the panel in the right side, inject the proper signal from a signal generator indicated by a color on the trace panel to the color dot test points, and when you see the signal from the speakers abnormal, check the voltages on the last stage where it was and compare voltage readings with the chart above. And this would also give you transistor readings, whether it's higher than normal or lower than normal, and then hints what you're supposed to do. And then of course, before you even start, make sure your batteries are clean, the corroded contacts are clean, check for switch problems, shorted plates, cracked panel, that sort of thing. Now in this video, I'm going to demonstrate how Philco trace works. I am actually going to troubleshoot a vintage transistor radio using a Philco trace panel. This is a 1960 model T62-124. Fresh from eBay. And more important, the seller said the radio did not work, which is exactly the way I wanted it to be to demonstrate this. Okay, so we have the basic tools that we need. Vacuum tube voltmeter, signal tracer, the radio in question, and the Philco trace board, as they call it, or panel, I think is what they call it. They call it a panel. Okay, so one of the first things that it said to watch for was to make preliminary checks. Check your batteries, check your corroded battery contacts, open switch, and whatever. So this is seeing it first time. This would be like somebody 1960 whatever happened to have all this stuff, and somebody's brought this thing in, although I have to say it's a little dirtier probably than most of that time period. People took care of these a little bit better. They require a little bit of money. So first thing I'm going to do, he says it doesn't do anything. So let's pull up here. And we undo the back panel. There's our circuit board. And already I see a problem. These two terminals are very dirty. These aren't so bad down here, but these are. So before I do anything else, take a Q-tip and some metal polish, and we're going to clean those up. Okay, I read the diagram of how to put the batteries in. The terminals have been cleaned. They're installed. Here's our volume control. Let's see what this thing does on first power up. A little pop. Let's tune it. Nothing. I'm checking for hiss right now. There's crackle. There's only a crackle and a plop when the switch is activated. So this is one time I'm glad the eBay person said this doesn't work, because this is exactly what I'm looking for. Alright, so our radio does not work. We're going to set the radio like this. Here's our panel. And the idea, you fold these little tabs, and I've already cut out all the holes for this one for demonstration purposes. The idea is to hold it like this. There we go. And there is your board. You're all set to go to do signal tracing. Okay, I made a small mistake. They don't want you using a signal tracer. Rather, they want you to be using a signal generator. So I'm going to use my Sencor stereo analyzer. It's got an AM signal generator built into it, and we'll go ahead and proceed with this. First thing I'm going to do, as soon as I adjust this, let's bring that in just a hair and then lower us down gently. Good. Now if I'm correct, I need to go up a little bit. There we go. First thing I'm going to do is check the audio. And under this it says audio, you inject a signal of 400 Hertz, which I've got over here, 400 Hertz square wave. So we check the greens. So let's start up here. This is the output. Oh yeah, we got signal. Got signal. Good. 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 Little weaker there. Little weaker there, but that's alright because this is your output, this is the driver. So that's good. Go down to here. We know this is very good then. If this is all giving us signal, this is all good. Audio is good. Driver. Good. Weaker. And we got that. Alright, so now we know audio is working just beautifully. Couldn't be better. Now, what we're going to do is check the IF. The IF requires 455 kilocycles, which I happen to have right here. That's been adjusted. Now we're going to check the reds. So we go through. Red here. Ooh, it's barely there. Louder here. I hear it. Little weaker. Little weaker. Weaker. Still hear it. I hear nothing. I can go through here and I just don't hear anything at all. Right along here is where it quits. Now, just for snicks and grins, I don't think we're going to get anything. In fact, I know we're not going to get anything, because if we gotten this far and it's quit, the last section you hear is RF, which is 1600 on the high end of the AM band, which you'd set on the signal generator and let that go through, but since it stops here, there's no point in it. So, we now know audio's working beautifully. IF is a little bit touchy. So what we need to do is to do some voltages along here and see what we get. Okay, the next step we need to do is voltage checks all along this section here. And to do that, I have vacuum tube voltmeter all set to go. So, without further ado, do the herky-jerky here. We're tightened in. Got my probe, and we'll start doing checks on this. Let's start here. Second IF transistor. Collector says 0 volts. Indeed, 0 volts. Emitter 1.7. I think we're lucky we get half a volt on that one. Base 1.5 volts. Same thing. Less than half. Now we'll go to the first IF transistor. Collector 0 volts. Nothing. That's the way it should be. Emitter 2.4 volts. We're not even getting that. Base 2 volts. Not even getting a quarter. So we know there's a problem along here. Now to check to say, okay, are our voltages correct? Here's a spot here that says 3 volts, B+. Put that in. Boom, 3 volts. So what we've got to find out is what is in this section over here. I'm going to give you 3 guesses probably what it is. It's probably an electrolytic. Let's go ahead and take this apart. And the way to do that, let me tighten this up. My ground connection I was using over here for my voltages. You pry this section up here. There we go. It's held by little clips. Very gently. Lightly tug at the plastic. It will let go of the circuit board. One last one over here. And there we go. Now our problem was in this section here, so if we flip this over, looky there. There is possibly where our problem's at. Or, no, there's even one over here. There is an electrolytic right here. So what I'm going to do, just for snicks and grins, I'm going to replace this electrolytic that's down in here. I don't know if you can see it, but it's barely here. It's a little black one. And I think it's about 10 microfarad, 3 volts. That's right in the heart of everything. In fact, I'll show you. Alright, we have it apart. There is our problem child, I can almost guarantee you, because we had just checked all the voltages along here, up to there, and this is the culprit that's got to be in between. That is a 10 microfarad, 3 volt electrolytic. So I've probably got a 4.7 slouching about here somewhere. Let me go grab it, install it, and let's see if that does any improvement. Our electrolytics has been replaced. So without further ado, let's test it. Turn it on. We have sound. So now it's just a matter of taking this thing apart, cleaning it, and getting it back together. All because of a little troubleshooting from Philco Trace. And here's the final product. Working Philco transistor radio. All set to go. Thanks to the troubleshooting of this little product made in the same time that this radio was, around 1960. Philco Trace.